The moon has been keeping a secret for 57 years. Not a rumor, not a theory. A secret buried inside a classified transcript, locked in a government archive, and carried in silence by three men who chose, deliberately, calculatingly, never to tell anyone what they had heard. And 9 days ago, 4 human beings flew directly through the middle of it. In May of 1969, 3 men in a spacecraft called Apollo 10 passed behind the far side of the moon. They were cut off from Earth. No radio contact, no backup signal, no lifeline to Houston. Just 3 human beings sealed inside aluminum and steel, drifting through the most complete isolation any living person had ever experienced, for about an hour. They were, at that precise moment, the most isolated human beings who had ever lived on this planet or off it. And somewhere in that silence, a sound started bleeding through their headsets. A rising, oscillating, almost musical tone, coming from a place where, by every rule of physics they had been trained to understand, nothing should have been audible at all. They did not report it when they got home. They did not mention it in their debriefs. They buried it for decades. The transcripts were classified, then declassified, then ignored, then rediscovered. And on April 6th of this year, the crew of Artemis II flew the exact same stretch of sky. 4 human beings in a capsule called Integrity, drifting through the same region of space, the same silence, the same electromagnetic envelope that had produced that sound half a century earlier. This is what those Apollo astronauts heard, why they stayed quiet for the better part of their lives, and what the question becomes now that 4 more people have just come back from the same place. To understand why any of this matters, you have to understand how genuinely strange the far side of the moon actually is, not in a science fiction sense, in a physics sense, in a cold, measurable, engineering, verified sense. Most people still call it the dark side. That name has been embedded in popular culture for so long that it feels true. But it is wrong. The far side of the moon receives exactly as much sunlight as the near side. The moon rotates synchronously with its orbit around Earth, which means the same hemisphere always faces us. But that does not mean the other hemisphere is dark. It means it is simply turned away. It gets day and night, just like everywhere else on the lunar surface. What it does not get is us. It does not get our radio, it does not get our voices, it does not get our television signals, our military radar pulses, the background electromagnetic hum of a civilization that has never once in the last 100 years stopped broadcasting in every direction. The moon itself, 3,474 kilometers of solid rock, compressed by billions of years of gravitational settling into one of the densest and most radio-opaque natural objects in the inner solar system, sits between that hemisphere and every transmitter humanity has ever built. A natural shield of incomprehensible scale. The moment a spacecraft slides behind it, every frequency humans have ever used simply dies. All of it. Gone. Instantly. With a finality that ground controllers describe as one of the most unsettling experiences in the history of spaceflight. It is the quietest place any human being has ever traveled to. Not quiet in the way a library is quiet, or a field at 3 in the morning is quiet. Quiet in the way that a room with no walls, no air, and no universe behind you is quiet. A silence with nothing on the other side of it. And quiet, as Apollo 10 learned in May of 1969, is not the same as empty. Apollo 10 was a dress rehearsal, 2 months before Neil Armstrong pressed his boot into the powdery regolith of the Sea of Tranquility. NASA sent Thomas Stafford, John Young, and Eugene Cernan to do everything the landing mission would do, except the landing itself. Fly to the moon, enter orbit. Undock the lunar module. Drop it down to within about 15 kilometers of the surface, close enough to read craters, close enough to feel the pull of the terrain, close enough that the landing radar could lock on and confirm the systems were ready. Then climb back up, redock with the command module, and come home. It was supposed to be the routine part of a historic sequence. The boring mission before the famous one. The test run. Nobody writes books about dress rehearsals. It was not routine. When the spacecraft passed behind the moon and lost radio contact with Houston, the onboard voice recorders kept running. They always kept running. That was standard procedure. Everything was captured. Everything was archived. Everything would eventually be reviewed. Stafford and Cernan were inside the lunar module, which the crew had nicknamed Snoopy, a name that now feels almost unbearably poignant given what was about to happen to their reputations inside it. Young was alone in the command module, Charlie Brown, alone in a way that very few human beings have ever been alone, with an entire planet between him and the nearest other person on Earth, and only 2 colleagues inside a separate spacecraft a few hundred meters away. And at some point during that radio blackout, a tone started coming through their headsets. Not a click, not a pop, not the ambient static that astronauts had been trained since day 1 of their careers to classify, ignore, and log as equipment noise. This was something different. A whistle, oscillating, rising and falling, changing pitch in a pattern that felt deliberate, felt structured. The way music feels structured, the way a voice feels structured, even when you cannot make out the words. One of the men describes it on the tape. The phrasing is careful, uncertain, reaching for language that does not quite exist for the experience. Yeah, it sounds like, outer space type music. Outer space type music. You can hear the disbelief in their voices when you listen to the original recording. These are test pilots, fighter jockeys, men trained to the edge of human physiological performance, trained to be the least likely people on Earth to hallucinate, to misperceive, to let their imagination interfere with their instrumentation. And you can hear them asking each other, quietly, carefully, almost as if they are afraid to say it too loud, whether they are really hearing what they think they are hearing. At one point, one of them says the quiet part out loud. Shall we tell them about it? The other hesitates. You can feel the weight of that pause, even on a 50-year-old recording. No one will believe us. They did not tell them. Not in the mission debrief, not in the official report, not in the press conferences, not in the books that were written about the Apollo program in the years that followed. The transcripts were eventually declassified in 1973. The audio was uploaded to NASA's public servers in 2012. And for most of the intervening decades, essentially nobody noticed. It was only in 2016 when the Science Channel produced a documentary episode specifically built around the recording that the story reached the general public for the first time. And when it finally got out, the astronauts were asked the obvious question. Why the silence? Why hide something like this for nearly half a century? The answer tells you everything about what it actually meant to be an astronaut in 1969. Not the polished, flag-planting, history-making version of what it meant. The real version, with all the institutional pressure and career anxiety and carefully managed psychology that the space program never advertised. They were afraid of being grounded. NASA had a standing policy, not a rumor, not an informal understanding, but an explicit policy, that any astronaut who reported a hallucination, an unexplained sensory perception, or any sign of psychological strain could be removed from flight status permanently. One meeting with a flight surgeon could end a decade of training. Just one mission earlier, Apollo 9 astronaut Rusty Schweickart had admitted to severe motion sickness during his spacewalk. He had been honest about it, and he had paid for that honesty. His subsequent career in spaceflight effectively ended with that admission. So when 3 men, in the most isolated environment any human being had ever occupied, heard something they could not explain in a place where nothing should have been audible. They made a calculation. They weighed what they had heard against what telling the truth might cost them. And they kept it off the record. They flew the rest of the mission. They came home. They shook hands with the president, gave their press conferences, filed their reports, and for most of their lives said nothing about the whistle on the recording. Whatever they heard was strange enough that they believed it could end them. Here is a detail that complicates the story further, and almost nobody outside the historical record talks about it. Apollo 10 was not the only crew that heard it. 2 months later, Apollo 11 flew the same trajectory. When Neil Armstrong and Buzz Aldrin descended to the surface in the lunar module, Michael Collins was left alone in the command module, more alone, in a very real sense, than any human being before or since. The crew in the lunar module was below him on the surface. Houston was on the other side of the moon. Collins orbited the far side every 2 hours, dipping in and out of radio contact, a pattern he would repeat dozens of times over the next 21 hours. And he heard it. He wrote about it in his memoir, Carrying the Fire, published in 1974, one of the most technically honest and psychologically candid accounts any astronaut has ever written. His description of the sound is almost word for word what Stafford's crew had recorded. A strange noise in his headset, an eerie woo-woo sound, he called it, unmistakable, unexplained by anything in the moment. But the crucial difference was that Collins had been briefed. By the time Apollo 11 launched, NASA's engineers had already been through the Apollo 10 recordings, had already developed their interference theory, had already built an explanation they were confident enough in to pass to the next crew as a heads-up rather than a classified secret. Collins climbed aboard his Saturn V rocket, knowing that at some point, on the far side of the moon, his headset might produce a tone that would sound like nothing he had ever heard in training. Had I not been warned about it, Collins wrote, it would have scared the hell out of me. That single sentence is the quiet heart of the entire story. The most famous astronaut to fly solo around the far side of the moon, a man trained to the absolute edge of human composure, a man chosen from among the best pilots on the planet, admitted that without advance warning, what he heard would have terrified him. The Apollo 10 crew had no advance warning. They had nothing but 3 voices in a pressurized cabin, a recorder that kept running, and the decision about what to do with what they heard. Later, Apollo missions reported similar tones. The pattern was consistent enough that it became a kind of informal piece of institutional knowledge, passed crew to crew in the briefing rooms, rather than committed to official documents. You will hear something. Here is what we think it is. Don't worry about it. But Apollo 8 did not hear it. And Apollo 8 is the mission that transforms this whole question from a ghost story into a real scientific puzzle, because it provides the one piece of evidence that actually tests the engineering explanation against a controlled variable. Apollo 8 flew to lunar orbit in December of 1968, 5 months before Apollo 10, the first crewed mission to ever reach another world. 3 men, Frank Borman, Jim Lovell, and Bill Anders, spent 20 hours orbiting the moon, including multiple passes over the far side. They were cut off from Earth exactly as every subsequent crew would be. They were in the same electromagnetic environment, flying over the same terrain, exposed to the same physics. They did not hear a whistle. They did not report any strange tones. They did not describe anything resembling music, or oscillation, or anything at all unusual in their headsets during the radio blackout. And the reason for that absence is sitting right there in the hardware manifest. Apollo 8 did not carry a lunar module. It was a command and service module alone, with a single VHF radio system, not 2. No second transmitter, no neighboring antenna, no pair of signals on close frequencies that could interact and create a beat tone. The sound that Apollo 10 heard, that Apollo 11 heard, that later missions heard, never appeared on the one lunar flight that was structurally incapable of producing it. That is as clean a piece of negative evidence as the interference theory has ever had. It is also the reason most communications engineers who have studied the Apollo hardware in detail consider the mystery effectively solved. Two VHF transmitters in close proximity, operating on slightly different frequencies, produce what is called a beat frequency, an interference pattern that to a human ear sounds like an oscillating tone, a whistle, something that rises and falls at a rate determined by the difference between the two frequencies. When those transmitters are flying in the unusual electromagnetic environment of low lunar orbit, with its complex surface reflections and the absence of any ionosphere to disperse stray signals, the beat tone can be clean and persistent enough to sound, to an exhausted astronaut in a pressurized suit, like music. Add the psychological weight of being millions of kilometers from the nearest human voice, sealed inside a metal container you have never tested in this exact environment, orbiting a dead world in complete radio silence. And a minor audio artifact does not stay minor for long. It scales. It occupies the silence. It sounds, as one man said, like something. So the official NASA explanation, when the story was finally forced into the public record in 2016, was exactly this. The interference theory is clean. It is physically coherent. It fits the hardware. It explains the absence of the sound on Apollo 8 with elegant precision. It also is not the whole story. Or at least, that is the position held by a small number of people who were in the program and never quite accepted the engineering explanation as complete. Al Worden, the Apollo 15 command module pilot, was one of them. Worden was not a credulous man. He was a test pilot with a physics degree from the University of Michigan, a man who had spent his career being professionally skeptical of anything he could not measure. And he pushed back on the interference theory, not because he believed in UFOs or supernatural explanations, but because he trusted the judgment of the Apollo 10 crew more than he trusted a theory built after the fact. The Apollo 10 crew knew exactly what their equipment sounded like, Worden said in later interviews. If they heard something unusual, there was probably something unusual to hear. No one has ever produced a clean laboratory reproduction of the specific waveform recorded on those tapes using only the VHF interference model. The explanation fits the available evidence. It accounts for the key observations, but it does not fully reproduce every characteristic of the signal that was captured. And Eugene Cernan, who would go on to become the last human being to walk on the surface of the moon during Apollo 17, was asked about the sound in interviews decades later. He was always careful with his words. He said he did not remember it frightening him at the time. He acknowledged the hardware explanation, but he also never quite said the words you would expect from a man who was entirely satisfied. He never said, "I know what that was." He said something closer to, "I know what they say it was. There is a difference." And Cernan knew how to use language precisely. Fast forward to April 2026. For the first time since December of 1972, 4 human beings left low Earth orbit. The Artemis II mission lifted off from Kennedy Space Center, carrying Reed Wiseman, Victor Glover, Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, aboard an Orion capsule they had named Integrity. They were not landing. They were flying a free return trajectory, a 10-day arc that took them up around the far side of the moon and back to Earth on a path that required no engine burn to return. A modern rehearsal for the surface missions that the Artemis program promises to deliver within the next few years. On April 6th, 5 days into the flight, they passed behind the moon. They lost contact with Houston. For several minutes, they drifted through the same silence that had surrounded Apollo 10 in 1969. The same electromagnetic dead zone. The same separation from every signal humanity has ever produced. the same stripped-down aloneness, except that Artemis II went further. At their closest approach, integrity came within about 4,600 miles of the lunar surface, lower than any free return trajectory in the history of crewed spaceflight. And from there, on the outbound arc, they coasted to a peak distance of more than 252,756 miles from Earth. That broke Apollo 13's record, the record set by a crippled spacecraft whose crew was trying to survive, not explore. Wiseman, Glover, Koch, and Hansen became, measurably and officially, the 4 humans who had ever been furthest from home. More minutes of silence than any Apollo crew, more distance between them and every human voice on Earth. A longer, quieter window than anyone before them had ever had. If anything unusual exists in that region, anything electromagnetic, anything acoustic in the structural sense, anything that the hardware of earlier missions was capable of producing, Artemis II had a better window to detect it than any previous mission. What the crew observed in that window is already a matter of public record, and it is remarkable. During their closest approach, as they swung around the far side and the sun's angle dropped behind the lunar limb, Integrity's crew witnessed something that no spacecraft camera in history has been fast enough to capture. Micrometeorite impact flashes on the surface below. Small white to bluish-white pinpricks of light, each one lasting roughly a millisecond, about as long as a camera shutter opening and closing. Rocks the size of a fist or a marble or a fingernail, traveling at 30 kilometers per second, slamming into the regolith and vaporizing on contact in a burst of heat and light so brief and so bright that only a human eye, dark adapted to near absolute lunar darkness during a total solar eclipse, could register them. The crew counted at least 6. Back in Houston, when the descriptions came through, lunar science lead Kelsey Young has said the science team audibly screamed. Nobody had anticipated the crew would see any. The eclipse geometry had created a fortuitous window. The surface was in total darkness. The crew's eyes were fully adapted, and the impact rate happened to cooperate. 6 flashes. 6 discrete data points about the micrometeorite flux in the lunar environment. Data that future surface missions will depend on, because a pebble moving at 30 kilometers per second does not stop at habitat walls. It goes through them. The crew named 2 craters visible from their approach path. One of them, named for Reed Wiseman's late wife Carol, was a quiet and human gesture at the edge of the cosmos. That is what the Artemis II crew has publicly said. They observed the eclipse. They witnessed impact flashes that changed what lunar scientists understand about the near-surface impact environment. They experienced the Earth set, the sight of their home planet dropping below the lunar horizon in a moment that Hansen described as the most profound visual experience of the mission. They expressed awe and described the silence as something more than merely the absence of radio signal. What they have not said, at least not yet, as of this recording, is anything about sound. Nobody from the Artemis II crew has mentioned a whistle. Nobody has described a tone they could not explain. Wiseman, Glover, Koch, and Hansen have been public, thoughtful, and specific about nearly everything else they experienced behind the moon. On the subject of the one specific thing their predecessors buried for 40 years, they have said nothing at all. That silence can be read 2 ways. The first reading is the engineering one, and it is probably correct. The Orion capsule runs on digital radio systems with completely different architecture than the VHF analog equipment aboard Apollo-era spacecraft. The specific conditions that created a beat frequency inside the Apollo command and lunar modules, 2 analog transmitters on close frequencies, physically proximate in the unusual electromagnetic environment of low lunar orbit, simply do not exist aboard Integrity. Different hardware architecture, different frequency bands, different signal processing. The interference theory does not predict a tone on a spacecraft that lacks the physical prerequisites to produce one. If the theory is right, the Artemis II crew heard nothing unusual, and the case is closed. The second reading is more uncomfortable. The old policy that scared Stafford and Young and Cernan into silence, the rule that a strange perception could end a career, has officially been retired. NASA now explicitly states that anomalous observations are scientific data, not grounds for removal from flight status. The stated culture has changed. But whether that policy holds when a specific astronaut, with a specific career at stake, sitting across from a specific flight surgeon in a specific debrief room, has to actually decide whether to report something they cannot explain. That is a question NASA has never publicly tested in a high-stakes environment. It is one thing to change a rule on paper. It is another thing entirely for a human being in an institutional context to trust that the rule will protect them when it matters. It took the Apollo 10 crew more than 40 years to speak freely about what they heard. The Artemis II crew has been back on Earth for 6 days. So, where does that leave us with the physics? Let us be honest about what we actually know and what we do not. The Moon sits inside Earth's magnetotail for several days each month. The magnetotail is a long plume of charged particles that our planet drags behind it through the solar wind, a trailing structure that extends millions of kilometers downwind of Earth and fills that region of space with plasma at densities and energies that vary in complex, nonlinear ways. When a spacecraft moves through variations in that plasma, charged particles can induce small currents in antennas and exposed metal surfaces. Those currents produce electromagnetic signals. Depending on the frequency and amplitude, those signals can be converted into audible sound by the spacecraft's audio systems. This is not theoretical. It is a documented phenomenon. It has been measured. It produces what engineers describe as broadband noise, a rushing, hissing, chaotic background signal that sounds roughly like a river, or wind, or a recording with the gain cranked too high. It is detectable. It is real. It almost certainly contributed something to the acoustic environment aboard every Apollo spacecraft that entered the magnetotail, and it almost certainly contributed something to the acoustic environment aboard Integrity. But plasma noise is not a clean, oscillating whistle. It does not change pitch in a structured way. It does not sound like a voice, or a flute, or music. It is noise, not signal. The distinction matters. Then there is the Moon itself. The Apollo 17 seismometers, the most sensitive instruments ever deployed on the lunar surface, left operating for years after the mission and generating an irreplaceable scientific archive, detected events called moonquakes. Hundreds of them. Some shallow, some deep, some so deep they probably originate near the lunar core itself. Recent analysis of the old Apollo seismic archive, cross-referenced against orbital impact flash observations, has identified roughly 1,700 impact-related moonquake events in the historical record. Some of the large ones were powerful enough to roll boulders downhill across the surface. The largest recorded events could theoretically collapse crater walls. Moonquakes produce infrasound, vibrations below the threshold of human hearing, typically below 20 Hz. Infrasound can, under certain physical conditions, couple into the structure of a nearby spacecraft and create audible resonances inside a pressurized cabin. The pressurized volume acts as a resonant cavity, translating structural vibrations into airborne sound. Could a sufficiently powerful moonquake, timed precisely during the Apollo 10 radio blackout, have driven the acoustic environment inside Snoopy and Charlie Brown for a few minutes? The honest answer is, it is a stretch. The energy levels involved at the altitudes the crew was flying, roughly 111 kilometers, are several orders of magnitude below what would be needed to produce audible resonances of the kind described. But it is not zero, and the honest scientific position is that nobody has run the specific experiment needed to definitively rule it out. And then there are the answers that live in less comfortable territory. The far side of the moon has only been mapped in serious detail over the last 20 years. Lunar orbiters, Kaguya, Lunar Prospector, the Lunar Reconnaissance Orbiter, China's Chang'e series, have found magnetic anomalies on the far side. Patches of lunar crust that still carry residual magnetization from a core that went cold billions of years ago, preserved in the rock like a fossil of a magnetic field that no longer exists. Some of these anomalies are strong enough to deflect the solar wind locally, creating miniature magnetospheres, tiny bubbles of unusual plasma behavior scattered across the far side surface, none of which have been fully cataloged or characterized in terms of their electromagnetic behavior at the frequencies spacecraft systems operate on. Whether any of those anomalies could translate into audible signals inside a spacecraft is not currently known. Nobody has modeled it in sufficient detail. The instruments needed to test the hypothesis have not been flown. Apollo 10 was, in a meaningful sense, the only experiment that has ever been run on this question, under conditions that might reveal it. And it was run by people who did not know they were running it. Artemis 2, whether the crew realized it or not, was the rerun. Imagine being Christina Koch. Strapped into your seat inside Integrity, visor up, the moon filling your window on one side in a way that fills your entire peripheral vision, Earth gone from sight entirely on the other. The cabin is at its quietest. The digital radio systems are in blackout mode. The only voices within any possible range of your ears are the 3 other human beings floating beside you. Below, on the darkened surface, you are watching pinpricks of light flare and vanish. Each one a rock, a pebble, a grain of sand, a chip of stone, disintegrating at 30,000 meters per second in a flash of kinetic energy, too brief for any camera to catch, but not too brief for an eye that has been adapting to the dark for the better part of an hour. You have counted 6 of them. You are still counting. And then somewhere in that silence, not from the radio, not from a crewmate, not from any system you can identify, a tone begins, rising, falling, oscillating with a regularity that does not feel like static. It feels like it has a structure. It feels like something that knows it is being heard. You look at the person beside you. Their expression tells you everything. That is what Apollo 10 described, in voices recorded on a tape that almost nobody heard for 47 years. That is what Apollo 11's lone occupant heard and wrote about in a memoir that told the truth about things most astronauts kept private. Whether it happened again on April 6, 2026, is something that only 4 people on Earth currently know. And they have not said. There is a reason this story has traveled across 5 decades of spaceflight history and landed here, in the week after the most distant crewed mission since 1972. It is not because anyone serious believes the moon is haunted. It is not because the sound was of alien origin, or supernatural, or produced by anything other than equipment interacting with a complex electromagnetic environment. It travels because it touches something honest about what exploration actually feels like from the inside, as opposed to how it looks from the outside. We have a narrative about astronauts. We have built it carefully over decades. The test pilots, the engineers, the mission-ready, checklist-following, clear-eyed technicians of human courage. The people who see through the noise, filter the variables, trust the instruments. The people who are, by selection and by training, the least likely individuals on Earth to be confused by their own perception. And yet, 3 of those people, in 1969, heard something they could not explain in the quietest place any human being had ever been. They chose silence over professional ruin. They carried the weight of that decision for the better part of their lives. And when one of them, Cernan, the last man on the moon, a man who had earned the right to say whatever he wanted about whatever he had experienced, was asked about it in his final years, he was still careful, still precise, still choosing his words like someone who knew that some experiences do not fit neatly into the vocabulary available to describe them. The far side of the moon is not the darkest place humans have ever been. It is the quietest. And quiet, in the real sense, the sense that Apollo 10 learned and that Artemis 2 has just rediscovered, has a way of surfacing things that noise hides. Not necessarily supernatural things, not necessarily inexplicable things, but things that the constant electromagnetic background of human civilization drowns out before we ever get close enough to hear them. Integrity came back, carrying the most sophisticated recording equipment ever flown past the moon on a crewed mission. Digital systems with frequency resolution and sensitivity that would have looked like science fiction to the engineers who built the Apollo 5 HF rigs. Its data is now being analyzed, frame by frame, frequency by frequency, by teams at Johnson Space Center. Whatever the crew heard or did not hear during those minutes of radio silence is on those drives. Whether any of it makes it into the public record depends on three things: what the analysis shows, what the astronauts decide to say, and what NASA decides to release. Maybe the archives come back clean. The VHF interference theory, finally tested against hardware architecturally incapable of reproducing it, will be confirmed by the absence of the signal it predicts would be absent. That would be a quiet scientific victory, the kind that never makes headlines, that gets filed in a technical report that 17 people read, and that closes a case that has been open since Cernan whispered about outer space music into a voice recorder over a dead world. Maybe the archives come back with something else, a signature that does not match any known electromagnetic source, a frequency that was not supposed to be there. Something that sends engineers back to the 1969 recordings with new questions instead of old answers, and forces a re-examination of what was actually in that region of space that Apollo-era hardware was picking up. Or maybe Wiseman, or Glover, or Hansen, weeks or months or years from now, will be asked the question directly in an interview and will answer it the way Michael Collins answered it. Honestly, precisely, with the specific quality of candor that comes from a person who has decided that the truth matters more than the comfort of institutional narrative. Maybe they will say exactly what Cernan used to say, which was nothing in particular, delivered with a look that said everything. We built a story about what it means to go to the moon, triumph, technology, mastery, flags and footprints. The moment when human beings proved they could do the impossible and brought back rocks to show for it. That story is true, and it has always had a quieter counter-narrative running underneath it, one that the astronauts themselves mostly refused to tell publicly because the cost of telling it was too high, and because some experiences resist the language you are given. They were not just visiting a dead rock. They were dipping into a place that did things they could not always fully account for. Equipment behaved in ways the engineers had not predicted. Instruments picked up signals nobody had briefed them to expect. Headsets played tones that did not match the wiring diagrams, and most of it got filed under noise. Most of it got marked anomalous and set aside. Some of it got passed crew to crew as whispered warnings between one lunar traveler and the next, the way Michael Collins was told, climbing into a rocket that was about to carry him further from Earth than any human being had gone before. Now, for the first time in more than 50 years, 4 people have just returned from that same stretch of silence with better ears than any crew before them. Whatever is out there behind the moon, it has been there the whole time, waiting in the electromagnetic dark. We stopped listening for about 5 decades. We started again 6 days ago. And if the pattern holds, if the history of what happens when human beings go somewhere extraordinary and experience something they cannot immediately classify holds true, then whatever those 4 people actually lived through in their quiet hour behind the moon, we will not hear all of it today. We may not hear all of it this year. We may have to wait until one of them, a long time from now, in a different institutional climate, or simply at a moment in their life when the calculation tips differently than it did on the way home, decides that it is finally safe to say. There is one more thing worth sitting with before we close this out. The Apollo program produced 12 men who walked on the lunar surface. 12 people who stood on another world, looked back at Earth across a void of nearly 400,000 kilometers, and felt the full weight of what that distance actually means in terms of human experience. Most of them came back changed in ways they struggled to articulate. Edgar Mitchell founded an institute to study consciousness. Alan Shepard wept on the surface. Charlie Duke left a photograph of his family in the dust and has never stopped talking about what it felt like to leave it there. Gene Cernan's last words before climbing back into the lunar module were not mission speak. They were personal. He said he was not sure whether he was speaking to the moment or to the future, but that either way, the words had to be said. These were not mystical people before they left. They were engineers and pilots and military officers who had been selected for the opposite of mysticism, for their capacity to remain rational and functional under conditions designed to induce the opposite. And yet, almost without exception, the experience of traveling that far from Earth, of spending time in a place with no atmosphere, no life, no noise, and no human history, did something to them that their training had not prepared them for, and their vocabulary could not fully contain. The Farside radio blackout was just one part of that, but it may have been the most concentrated part. The few minutes when every connection to home was physically severed, when the spacecraft was at its most alone, when whatever the environment had to offer came through without the filtering noise of Earth's electromagnetic civilization. The Apollo 10 crew did not plan to discover anything in that window. They were doing systems checks and trajectory monitoring. They were doing their jobs. And then something came through their headsets. The scientific explanation for what they heard is probably correct. The interference theory is coherent, evidence-backed, and consistent with everything we know about how analog VHF radio systems behave in complex electromagnetic environments. But the experience of hearing it, in that specific silence, in that specific isolation, with no warning and no framework for processing it, that is a different thing entirely from the theory that explains it. The theory closes the scientific question. It does not close the human one. Because the human question is not really about what the sound was. The human question is about what it does to a person, to go somewhere that's strange and come back not entirely sure that what they experienced is something the people at home will believe or understand or be equipped to receive. The human question is about the gap between experience and language, between what a human being perceives at the edge of the reachable universe and what they can transmit when they return. Apollo 10 had that gap. Apollo 11 had it. Every mission that followed had some version of it. And Artemis 2, with its superior instrumentation and its changed institutional culture and its 4 thoughtful, articulate crew members who have spoken beautifully about nearly everything else they experienced, may have it too. We will find out. The data is being processed. The crew is being debriefed. The decisions about what to say and when to say it are being made right now, in real time, by 4 human beings who just came back from the furthest point any person has stood in 53 years. Whatever they carry back from that silence, they carry for all of us. That is what exploration has always meant. Not just the data, not just the photographs and the samples and the orbital mechanics. The carrying, the translation of experience that the rest of us will never have into something the rest of us can somehow hold. The moon has been keeping a secret for 57 years, and it is still keeping it. Partly because the science is genuinely incomplete, partly because the instruments we have sent have only recently become sensitive enough to ask the right questions. And partly because the human beings who have been closest to the answer have, almost to a person, chosen their words very carefully. That carefulness is its own kind of data. I hope you enjoyed this video. If you did, please take a second to hit the like button. It genuinely helps the channel reach people who would want to see this kind of content. And if you want to follow along as this story develops, because it will develop, consider subscribing. We will be here when the Artemis II mission data is released. We will be here when the crew speaks more openly about what they observed. And we will be here for whatever comes next, because this is the kind of story that does not end when the spacecraft lands. It ends when the last person who was there finally tells the whole truth.